Hey guys, welcome to Genius Learning. Today I want to do an integral. We see this common in E&M, these types of integrals, and we're going to solve this by trig substitution. Okay, so we can see just from this integral here we have z squared plus x squared, and we'll be using the formula a squared plus x squared will give us a tangent. So really we're going to do u substitution looking like this down here. And so if we do that, our trig substitution is going to be x equal to z tangent theta. Okay, and then we're going to take the derivative of dx of x to get dx. So we're going to have dx equal to z secant squared theta d theta. Okay, and so this is our trig substitution, and we're going to substitute these two values into this equation. I've outlined here where exactly we're going to put them. Okay, so here for the value of x, right, let's put z tangent theta, and for the value of dx we're going to write this right here. Okay, and this goes right underneath the dx. So there, so we have everything substituted, and now let's simplify it. Okay, because z is not a function of this integral, we can take it out. Okay, so let's see. Let's this z and this z is z squared. Let's take that out of the integral. Okay, and then we're gonna have the integral of secant squared on top. Okay, d theta, and on the bottom, let's combine this here. So we have z squared plus z squared tangent squared theta, and everything is raised to the 3/2. Okay, so let's simplify this bottom part here. Okay, it's going to be a little tricky, but we can get through this. So let's find an identity first, and we can always use the identity we know: cosine squared plus sine squared equals 1. We're looking for a tangent, so let's sine over cosine is tangent. So let's divide everything here by cosine squared theta, and cosine squared theta. Okay, and so this turns into 1 plus, here we have a tangent squared theta, and 1 over cosine is going to be secant squared theta. Okay, so let's hold on to this for a second. Okay, and we'll come back to our integral, and we need to identify some things. Okay, so we're going to leave this out. As usual, we're going to just write the integral. Let's leave the top part alone. Okay, and then the bottom part, let's pull out a z squared, and we'll just pull it out from the inside. So we're just going to have 1 plus tangent squared theta, right? And everything is still to the 3/2. You see, so I just pulled out this z squared from this term and this term, and I'm left with 1 plus tangent squared theta. So if you put this back into two terms, we'll get this, and everything is still raised to the 3/2. And so now the part that is a little bit tricky to deal with is going to be this term and this term once we change it into secant squared. So let's do that. So this here is secant squared theta. Okay, so our integral is going to look like this. Okay, we still have the same thing on top, and now the bottom part, we're going to have z squared secant squared theta. Everything is still to the 3/2. So everything is still raised to the 3/2, nothing has changed. Now let's deal with these two terms raised to the 3/2. Okay, so I'm going to do that over here. We're going to do z squared raised to the 3/2 first. So we have z squared raised to the 3/2. okay? And secant squared also raised to the 3/2, okay? So I'm gonna solve them separately here, but the answer is gonna be combined. I just wanna show separately how we're gonna deal with them and simplify them. So z raised to the 3/2 is the same thing as saying z 2 times 3, which is 6 over 2, okay? And then we're gonna have z raised to the 3, okay? So that's for that. And secant, the same thing. So, we have raised to the exponent 3 over 2. So we're gonna have secant to the 6 over 2, and that's gonna be equal to secant raised to the 3rd, okay? So that's what the entire bottom is equal to. So now let's write that. Let's write that over here. And so we still have the z squared from the outside, the integral of secant squared theta d theta. The top stays the same, and now the entire bottom has changed. Z squared to the 3/2 is now z to the 3rd, and secant squared to the 3/2 is now secant to the 3rd. Okay? So now it's much clearer to see what we can eliminate. Okay, we could take this z to the 3rd out here, and so if we have z squared, if we have z squared over z to the 3rd, right, we're just gonna be left with 1 over z, and that's what we're gonna write out here, 1 over z. The integral of, we have secant squared on top, secant to the 3rd on the bottom, right? And so we can write it as 1 over secant for our integral, okay? But we know that we have an identity which we can use. So 1 over secant is the same thing as cosine, and cosine is something that we can integrate and deal with better. So we're gonna change this 1 over secant to cosine. So we still have the 1 over z on the outside, and now we have the integral of cosine theta d theta, which is something that we can integrate and we know. And so then the answer is just gonna be sine. So let's do 1 over z, and we're gonna box this up. The integral of cosine is sine. And since we don't have any limits, we're gonna put plus c. And that's it. That's how we solve that.